Hey YouTube, Vsauce here. All right, let's go. What are we doing? Hey Vsauce. Wait, you're not Vsauce. You're Thinky Head. Today we're all Thinky Head. You're on my channel. You're Thinky Head. Hey Thinky Head. What's up? Are you Thinky Heading too much? If you're like me, you probably are. Well, anyway, I have a wireless mic. I'm not getting it. We're gonna still do this. I've got the thing up to full. I hope that's not too much. Let me know if it's blowing your ears out. Um, Welcome. Welcome, everyone. Today we put out a little release of Marlin for you, and we're working on better things for the future. But the name of this stream is Retro Atari Basic. So I guess that's what we're doing. I've been having a lot of fun. Well, I wouldn't say a lot of fun, Bob, but I had some fun with this project that I've been working on, so I'll open up a terminal with it. New window, Atari 800 style. I have this just ready to go in case I need it. Let's see, is this the one I need? Did I keep it on? Am I keeping it on my desktop these days? I don't think I am. If I was, I'd have to keep a copy of the script, but I want to keep, let's see. Atari Tools Helper. Hey, that looks like it. I have to do this con to activate. There we go. Right. Let's go back there. So I have a thing, it's called basic.py, P-Y, and it is, as you would expect, a Python script. And let's get that open in Python editor. Let's see, where is my editor? Let's put AI talk away for a minute. Come back to that. I'm going to do some AI stuff in a bit. Let me see. 6502 tools. Here we go. There you are. Basic. So I've got a lot of notes on this. I'm not going to bore you with, but let's go back to that. There we go. Put that away. And that. And there. I just want to keep want to keep this where I can see it. I want to keep you where I can see you. So I'm not sure why that chat, oh there it is, chat is good. Welcome to chat. So yeah, I decided to do this at 6 p.m. right in the middle of dinner time, but I had a bagel, so I'm good. Had some leftover pizza. And I got a little coffee to keep me going. Okay. So, oh, and I have a matrix screensaver to keep you going. So, I made a matrix screensaver for fun, in case you are looking for other things that are fun to do with your Mac or just retro stuff in general. It's built in JavaScript, so it just uses HTML, CSS to do the animation. Hey 3DHP, what's going on? Haven't seen you in a while. Merry Christmas, welcome. I'm retroing, but you know, retro and 3D printing has a long, venerable crossover. We got guys like Richard Horn using 3D printing to reproduce his favorite old candy bar, and occasionally cases for our Atari 800s and stuff. We can print them now, and if we got the right color. So at this point, I was just looking at my little Atari Basic toy that I've been building for myself, which it's essentially I just want to like tokenize Atari Basic into tokens so that I can load them up in Atari emulator without having to go through the list process. Which is very niche, obviously, but it's kind of cool because it's like the Atari Basic source code is out there and you can like grab it. And so I have that. And I've been, I went through it and I commented it up so that it matches the Atari Basic source book that came out in the 80s, even with the typos and everything. Then I cleaned it up and I provided a version and I did some annotations just to kind of get an idea of how it flows. And I don't know, it's a maze because it goes like, typical 6502 code. It doesn't have like clean loops and things. It jumps around. So it's a little hard to like turn it into something modern. But I got up to the point where I can like, okay, identify a token and or a command, and then decide which of these little blobs here. Oops, these little blobs, which are called. This is part of the BNF, which is it's all annotated, encoded versions of what the syntax should be for each command. And so if you have the wrong thing in the wrong place, it like knows and it can say, no, you shouldn't have a number there. That should be a string or whatever. So it can kick you out. And then once it gets through all of the rules and you pass them all, it says, okay, good command. And it encodes it and then moves on to the next thing. So, and if it fails, it has to like, be able to say, oh, the whole line is bad or whatever, or this is where the normally you in most code you'd say this is where it's bad, and then you'd mark it and you output an error. With this, you just like turn the whole line into an error, but whatever, it works. So I'm going to be doing that. So I started a little bit of it. That's what I was just like playing around with. At this point, all I can do is like list, hey, look, or C list, which is color list. I can list the code. So I can load already tokenized BASIC and list it. So I'll know if the tokenizing is working because, whatever. But if I start to tokenize, like say I type line 100, it's supposed to delete line 100. So if I had line 100, which there is a line 100, I think it's still there because I haven't implemented the actual delete yet. Yeah, it's still there. So I have to implement that, and if I were to say 100, print quote hello end quote. See, it's crashing because I haven't gotten that far, but it knows that it had command 40, which is a question mark, which is a print command, and then the next part was going to be, okay, now I have to run these esoteric weird things that aren't defined, and yeah, so I have to figure out a way to like make it do the whole what I guess you'd call the the BNF or binary. Is it BNF or BSP? So anyway, it's all encoded. It's very tricky, but I'll get it. I'll get there. We'll get there. I was trying to figure out whether I should have it like encoded as functions, where one thing calls the next and it builds up like a big. It's still going to use up a stack, but why not use the stack of the language, of Python itself? Or should I have it like, encoded the way it used to be, or the way it is in the program, which is a bunch of just numbers, and then use those as lookups and do a big old state machine and kind of like run that in a loop. So I may end up doing a state machine because it's the closest thing. We'll see, but this will all come together once I make an Atari Basic thing, and then I build and then after having this fun, I'm also building out some 6502 stuff, and then I'll take some of that and convert it into 3D models, and I guess put them on Thingiverse or something. I'll print them. But I did a stream earlier where I was talking about the release of Marlin I just put out 2126, and the next one that's coming up, which has got the new motion system. Pretty excited about that. I hope you are too. It's gonna be cool. It's smooth and fast and very well optimized, and I think we're working out the kinks. How, like things like editing while it's moving and editing, parameters while it's moving and stuff like that, and making sure it doesn't break too badly when you do that. Or it forbids you from doing it if it has to break. But we're trying to figure out ways to transition smoothly, although that does add a little overhead to all motion if we make, allowances for things like that. But we'll do what we can. Keep things moving smoothly. So this basic stuff has been pretty fun. The original Atari Basic source code is here. And you can see I've cleaned it up to make it look pretty much the same. Of course, this all has addresses and it's all compiled, or I should say assembled. So some of this stuff I had to change because the way the assemblers work now is a little different. And you could do this more closely in C, but you'd use a lot of goto. You'd basically build it with gotos and you might do some functions, but there'd be a lot of gotos, and then I could see how you could clean it up from there, though. That's kind of an interesting approach. I might look at doing that, is breaking it down into something. But right now, the only thing I'm really working on is I'm not trying to run the code. It's not even something I'm looking to do ever. The only thing I want to do is tokenize it, and so that I can load it into the Atari emulator as a BAS file. Produce a BAS file, and that's it. And that'll be enough for me. Also, this language is kind of archaic, and it's not my favorite BASIC at all. Well, it might be my favorite BASIC because I haven't used a lot of them. Visual Basic was okay. QBasic was okay. But this one is, it's slow. Like when you go to a line, it actually has to search through all the lines to get to the line that you want to go to. It doesn't have a direct, fast way to do that. It doesn't have any kind of table of where the lines are, so it can't for example, do a binary search and get there in square root of n time. So or I guess you would say log 2 time or whatever it would be. With this, you have to that's the way it works. It scans through the lines until it finds it. Which is why it's best to have anything you do frequently for GoSub or whatever at the top of your program. Yep. And if you can use goto instead of GoSub, you're better off. Just goto and then go2 back to where you started from. Although it might be that GoSub keeps the position rather than the line. I think that's what it does, is it goes back to the place in the whole program. So that GoSub might be more efficient, come to think of it. So don't listen to me. But goto, but all of them are really inefficient in general, because they, one of the things you have to do with this language is assign things to variables to keep the program smaller, because each number is 6 bytes minimum, I think, or maybe even 10 bytes, I forget. But yeah, a single number is the token to represent a number, and then the 6-byte value for the token. So yeah, you end up using up a lot of space just for numbers. So if you frequently use numbers like 0, 1, 2, 10, for your game or whatever you're writing, it's better off pre-assigning those to variables and just using those. And you only have 128 variables you can use, so you have to choose carefully. But in general, that's for performance. But in the real way to use Atari Basic was to write your stuff that needed to be fast in assembly, and then call that from your basic program. And then when you were done with your basic program, you would then compile it in using something like there's a couple different compilers. I have a couple of them. And you would basically turn it into P code, which runs like It's still interpreted, but it's smarter. It's like it works by doing like push this, push this, push this, then jump here to do the thing. So it's doing direct pushing of values, and it's also all oftentimes they're just like you have a flag, you can just have it turn everything into integers. So if you don't need any floating point in your program, which oftentimes is the case, you could have it all be much faster and smaller. And in general, some of them, I think that later on you had some basics that could almost convert straight into assembly, and were pretty much like almost compiled on the fly. But you can look at the history of basics on the Atari and on the Commodore 64. I went straight from basic to the macro assembler, or well, I think I used the assembler editor for that. Really sucked, and then it was okay, but the macro assembler was much nicer. And then when I got to use like DevPack, um, that was much nicer still on the Amiga. So, because of course you also there you have a much nicer language. So you can I use this as a reference. The basic programming language, like what are the error numbers I should emit and stuff. But in general, yeah, again, I'm not going to be running this stuff. I'm only going to be tokenizing it, so I don't really care about most of this. Um, I did some very interesting things back in the day on the Atari. Um, Most notably, I think towards the end, I wrote a. You can find it on archive.org. Is my the tracer. Tracer. It's an Atari program that was like a disk editor that someone had an unfinished version and sent it to me, and I was like, oh, thank goodness, because I lost everything else. But they sent me that, so I put it up on archive.org. But that's basically like something I was writing in Atari Basic and compiling, and then I was slowly replacing parts of it with assembly, and the version that's there is like definitely not complete. I was starting to actually write like a text editor, a little text editor, program editor inside of this program to basically have manipulation of disk bytes and sectors and stuff. So you could be like, load this sector, change this byte, write it back, and that kind of stuff to just basically have recipes for hacking disks or doing whatever, or making changes to disks for your own purposes. But it was mostly for, like you could use it to, I used it to go through programs that we'd like copied off of cartridges and then put on disk, and then it was easy to like, I put an assembler disassembler inside of the program so it could show you the 6502 code for what you were moving your cursor on top of. And if you wanted to put in assembly code, you could type it in. I mean, it was getting there. I mean, this is a really intense program for a 16-year-old to be writing, but I was having fun with it. But I also at that time wrote like I wanted my very big program to be printable, and my printer could not do Atari character set, of course, so I had to do it out in dot matrix, and with all the information about how to do graphics on the printer, I could write a driver. So I wrote a driver, and all the information about how to make a driver in Atari. And basically, with the Atari, it's pretty simple. You just replace some vector with your vector, and then you say, oh, if it's my device, then I take over. Otherwise, I call the old vector I took over to pass it on to the next device. So I think that was basically how it worked. And then once you had control of the device, you could do whatever you wanted to do as far as um, the parts of the stream that were already there. Like in this case, it was like a printer was a serial device and a parallel serial device, and you already had the printer itself, and all you had to do was just write commands in the stream as you were writing out to the printer device that was already there. So I didn't really have to do much except make a little translation layer, turn the characters sideways and spread them out into like 144. I don't know, I forget how many bits it was, but it was pretty cool how you did the graphics. And so I had a couple modes where it could be smaller or larger, so you could save paper or have it be more readable. I wanted to make it like a mode where it was more gray and less dark because it used a lot of ink, and of course it ate through the paper because the paper at that time wasn't great. So yeah, a lot of stuff to play with there. But that was the kind of stuff I was doing at that time, and I was even starting to write a game. But then things got kind of unsettled, and I had to move, and all my stuff got displaced, and I ended up like leaving it somewhere, forgetting about it. Yeah, yeah. All the stuff I did in my teens was just like, boop, I'm just gonna throw this away. I was very flippant in my 20s. I was just like, yeah, fuck it. Um, so now I have to kind of rebuild some of that stuff. So I'm looking to build a game and getting into the mode. One way to get into the mode was to go back to, looking at Atari Basic and the different commands you can use and the shortcuts that you have for the commands and all that. Figuring out how to encode it yourself. Initially, I had this whole thing where in Basic I had like I actually have an Atari Basic Syn. It was all in one script, so it was even longer than it is now. Um, but I broke it up into pieces. So make sure we can reveal it. Here we go. And so now I have a syntax, and this is the syntaxer that's not working yet. So this is just like my approach to the syntaxer, the encoded thing based on the original basic assembler sources. Expand. So there's a lot of like pieces to it that I kind of probably won't have to do literally, and that's what I'm kind of looking to is not do is do it literally. Here it's called ABML. So that's what they refer to it as. And so yeah, I have to learn. So I had to basically use this basic meta language, and so that's all there. And then there's a runner, and there's not going to be a runner, so that's just out the question. But I can implement things like list. I can implement things like save. So, um, and then since I'm going to be tokenizing, I can implement things like tokenizing lines into the program as you type them, and then saving that, and then so you get kind of close, but I won't have a runner. I'm not going to be able to run anything on this at all, especially as like it's there's a lot to Atari Basic. Like it depends on the hardware and the different graphics modes and stuff. So then I also have this Atari Basic, this is the actual Atari Basic stuff here. So the commands have their token IDs and so on. So I think I do include that. Yeah, I include that. So um, into the namespace. So statement table. Um, and I think the way I ended up traversing the statement table, like right now, it's like there's this whole idea of like I know what the minimum length of a thing is, but I never use it. Like even though I set this thing called minimum length based on where the dot is inside of here, like dot can work for rem, d dot is data, but also da dot or dat dot can work as data. So that's the minimum length, but it can be longer. So all of these are like that. Go to actually geo space period. It will treat it as a go to. Found out. Turns out. So all these things like it can actually look for. So I put them in there, but it doesn't use them. Instead, it uses name um, and as for abbreviation is just used for um, that dot space. Okay, is it's just used for when you do the listing, gives you the abbreviations. Um, and if we look down, we can see this doesn't do a whole lot. Gets the line number, searches the statement table. So these parts are working. The next part is like the BNF stuff, which is not yet. um, or the ABML stuff to go through that. So, yeah, I'm not sure how I'm going to approach it yet, but I think one thing I need to do is take it and put it into a class. So it's in Syntaxer, and then each thing needs to be calling. I wanted to have it so it could do this without having to do self, but they all have to have self on them, as it turns out, and you just have to do it that way. So all the things that have, you know, all these calls I have to do like self dot on the front of all of them. So it's a lot of typing. Look forward to. um, and then the same here. There's the statement syntax table. So yeah. So annoying, but must be done. I was looking for some way to like eliminate having to type self, but there isn't one. Just have to do it. Just have to live with it. So my thing through this error were FD1 and FEOS. Didn't know what that was, so I could get through fixing that with this. Yeah. See if that saves it. Yeah, got further. so eventually, if I do that, it'll go through all these. What's interesting is like most of them just refer to other rules and they don't do much. But some of them look for a particular character or a very particular construct or whatever. So the ones that come down to just like a single character are the very simplest rules. And the ones that come down to like, calling other rules are like more complicated rules, obviously. And then the cool thing is they can kind of not necessarily recurse, but they can kind of recurse. If you enter into an expression, it could contain an expression, so it looks for that, and then it checks to see if the thing that it's evaluating is stuff that can be in an expression. So it doesn't decide it's an expression. It basically just decides these are the rules that can apply to things in an expression, and it's like there's an expression that ends an expression and there's an expression that continues an expression. So you have expression that continues is an expression with another operator, and the expression that is finished is just expression with no continuing operator. So you check the first one first with the operator and you check the next one. Yeah, it all has to follow in a very certain order, which was all worked out back in the day. So now the tricky part is I did turn these all into calls, which I think was the right call. So now, yeah, I'm going to have to go through this bloody process of self.f underscore for a replace where there's an underscore inside of a thing. Yep, over and over. That was going to be worse, but it's not as ugly as I thought it'd be. Putting F on the front of everything helps because it makes it more obvious that these are internal rules. Oh, I could do is maybe if I do replace def self.f with, that'll take care of case we didn't want. Right? Oh wait, def. Oh, it doesn't exist. But that one does. There. So that takes care of that. And then we look for parenthesis with f underscore. And then those are going to also be parenthesis. I don't think there'll be too many of those. Take a look. There's one. Boop. So yeah, I was thinking that one thing that would be there besides space would be parenthesis. Oh, look, these are, yep. Sure enough. And I don't see any other cases. Well, so far. I haven't looked for other cases, but we'll look for things that aren't space in our parenthesis. And if that turns out to be all of them, then we'll be done. It's fun. Oh, too soon. There we go. Good. Oop. Great. Now I just gotta make sure tnvar is part of it. It is. So the ones that are just say pass, or obviously I haven't filled them in yet. Some of these do some deeper logic on the tokens themselves and read tokens, and then I don't know what happens when they fail. They go back. I'm not sure. We have to figure that out. But I'll look at the original code and we'll get some guidance from that. From the assembly code, which goes through these, and the ones that are marked as, let's see, is it ANTV? No. ESRT? I think these are the ones. TNVAR. Yeah, see, this is an actual routine. Some of them are just like references to other rules, but this one is an actual look at the, you know, see, what are we doing? We're doing a string test or a numeric test. So yeah, one of those, one over the other goes here. And then skips some blanks, gets the index, does the thing. So yeah, it knows how to look for what the rule says it should be. And then blanks are just ignored. They just skip over them in the front of things, which makes the most sense. The way this works is it just scans left to right. So if you spell something that's a command, but then you add more letters, it just assumes that the next thing is a variable or something. It doesn't assume you meant a longer command name. In that sense, you can't have command names that are shorter and longer because of that. Like you couldn't have draw and then draw two because of that rule. I think that's true. Like, because it would assume that draw two. Well, because it could, as long as it looked for the longer ones first. I don't know. rules. So either way, we're all good as far as that goes. And I encoded them here like this. So now that I've done that, changing them all to self, hopefully it cannot crash. Oh, self.erem. Yeah. I think it works like this. I don't have to say self because I might have to. I don't know. We'll see. We'll see what that does. Yeah, self go to is not defined in self trap. Okay. We have to look for things that say equals self. Get rid of those. So, whoops. One of the things I didn't consider. All right, I think we got it. Hey, okay. So now 100 print hello. Hey, so still sort of falling apart. F circant. See, what is this? One positional argument, but two were given. D1. Oh, self. Hello. So it doesn't like this for some reason. Let's see what that is. Okay. It takes a self token. Oh, it takes a self comma token. What's up? Okay, so that's okay. See what happens. 100. So yeah, basically these are supposed to just call each other and eventually. Look, it got there. It got somewhere. Tokenize and apply line. So it did tokenize line. What's the complaint? This is fun. Syntaxer has no attribute named result. Oh. Okay, yeah. The idea that I came up with was the syntaxer you would run it and it would generate all the tokens in a buffer, which is the outbuff that it uses in the original Atari Basic, called outbuff, of course, or line buff or something like that. And basically, then that is when it finally finishes that tokenization of that line, it then copies it into the program by expanding the program to make it bigger. Which all the offsets inside the program are relative. Nothing is like absolute, so it can push the lines around without affecting one line, knowing where it ends and where the next line begins. Because again, there's no like line number table that has to also be moved around. So in any case, that's pretty straightforward. So I was going to have a thing called result, which would give the after everything worked or not, you would be able to grab the line and then do some stuff with it, which I think is run BNF for command, and then it does result equals result. And let's see what if it collapses. These things are so small, it doesn't help to collapse them. So I have tokenize, which is going to do this thing, blah, blah, blah. So yeah, call the syntax table thing. So here we actually create it. This is just like, I'm not sure how else I might do this, but in any case, you do it once, creates this table that points to all these, and then you can look them up by index and then call them. And so now I have def result, I guess. Self. And this is, we'll just say pass for now. Turn, and I think it's supposed to return a binary buffer or something like that. Or bytes. And then it also is supposed to have some of these utils up here are for general use, and then let's see. So I guess init is where you'd create that stuff, huh? Although we do it here, so I don't know. Tokenize, I mean, when you init, you're kind of creating the object that you're going to run, and then tokenize is going to do the thing. And so I'm just going to say tokenized. And I guess, what do you say, like bytes, like that? And I do have a thing that calls it. Yeah, there's the command ID then. And tokenize is a buffer that already exists. So I'm supposed to like append to it and stuff, or clear it, or do other things to it. So without actually destroying it or replacing it. So to do that, well, this is a copy, and then something like that. Or maybe I'm supposed to do something like self-tokenized, but clear. I don't know. I mean, I don't know how much I guess I'm supposed to tokenize an entire line. And so the index is like where the tokenization starts, but it's supposed to just tokenize the whole line. So I don't know. I mean, this is obviously statement, not line. So yeah, so I guess we are just pointing to the tokenized buffer. So I don't want to clear it or anything. I just want to add to it. So let's do this much. Let's do self tokenized and I forget how this works. B test 1, 2, 3 colon. I don't know this. And return self tokenized, I guess. Line buff is the text that's coming in. Probably make notes about that, huh? And index into the buffer to tokenize or from, right? So it has to end with the end of the line or a line separator. And then, so that's lbuff. Could actually be bytes, I'm not sure yet. It's like a byte array, other thing you can have. I'm not sure I know the difference. I gotta check it out and see. And you have, of course, tokenized buffer to append onto. So there. So I'm just going to do the appending with fake stuff. That'll do. The colon in there too, just to make it neater. Now it's going to be fake, so that's fine. Hey, some things are happening. Bytes can't be interpreted as an integer. Well, I knew that, I guess. Let's see what I can do with that. Can't be interpreted as an integer. Oh, maybe that's where it can't do it, is the end. Let's find out what tokenized is before I go crazy here. Tokenized is... Tokenized line is a byte array called tokenized line. Oh. It is a byte array. Okay, good to know. I'm gonna just return the thing anyway. So yeah, I don't know what else it's gonna do from there. Yeah, same thing, right? Bytes object cannot be interpreted as an integer. Where, why, who? Result equals syntax or result. What's wrong with that? Not sure I'm doing that anyway. Is it happening? Result equals syntax or result. There it is. Run BNF. That's all it does. Is it goes here. Does the tokenized thing with the command ID and the line buffer and the current index, and then it returns the index. Okay. Something like that, just to give you a new index. That's for sure. So it would self-index. Something like that. lbuff is what? Because here it's bytes. Let's trust that. Might as well be specifying these types just to keep it neat. All right. Expected. I have to do it this way. Yeah. Bytes cannot be interpreted as an integer. Still giving me that. Is that because of the what's going on? Self-tokenized dot append. Let's see if we're doing anything here with tokenized in that regard. Well, there was an append here. That seemed to work fine when they did it there. Maybe I have to do one byte at a time. That. Nope. Nope. Help me out here. I need some advice from Python. I'm going to ask an LLM. I hate to do it. Do it. I have LM Studio just for this purpose. Just in case. Need to ask it a dumb question. How do I do it correctly? Question mark. Gotta pick a model. Which model? I'm gonna go with GPT-OSS here today. You have a favorite model? Let me know for your local AI needs. What a beautiful Christmas Eve it is. I would rather be nowhere but with you. Byte array is mutable. Yeah, I know. Boop, boop, boop. Self-tokenized plus, can I just use plus equals? Well, that's cool, but I don't know if plus equals will do it. I think that's the same as append, right? Maybe not. Let's find out. Oh, we liked it that time. I actually made it through. Oh my gosh. Okay. Let's look at it. Now, of course, none of this is that's would have to go through all of that to get through and be considered successful. I haven't. I guess I'd probably be throwing exceptions or something like that for fails. I'm not exactly sure. That's kind of getting, it gets closer to the way that 6502 works anyway. It's like, or the original basic source code works anyway. But it's kind of what I'm after, is just something that does the trick. But now that I have this actually running, does the BNF and doesn't fall apart, I should say the ABML syntax table. Yeah, there's a lot of stuff about it that's pretty cool. I'm really trying not to understand it too badly, too much, too deeply. I don't look at it, I just type it in and go, okay, you go there, you go there, you go there, everything lines up, good. So as long as all the rules are correct and I didn't make any typos, everything should work properly. All the characters are described correctly and all that kind of thing. So the next thing is like just it runs into the syntax table, and then each one has to decide if it passes or fails. So some of the things I'm going to need to do later is expanding and contracting things like this statement table and so on. Then I don't think I'll be needing that here. That's going to be happening in the other script. This is going to be more about just building the tokenized line buffer and then sending that back and saying, okay, here's the buffer that has the tokens that I added on to it. In fact, it doesn't necessarily even have to have like a full, like, depending on how it works, it could just tokenize the line anew into a fresh buffer with the ending on it either being a separator or a line ending. And that would be, all it passes back. And then that way, it would be kind of cool to do it that way because typically, you want to break things up into smaller units like that. And if I can do it that way, that's great. And then only pass that back. Awesome. And that's kind of what I'm going for here. One statement, tokenize it. Return back, but it is going to add it on to the tokenized thing. So plus equals does work, which is cool. It doesn't say anything about append. Or, extend. Maybe that's what I need to use was extend. Let's try extend and see if that works, just so we know. For later, that it's a legal thing. Okay, cool. And then it shows me some extra tokens. That's cool. Yeah, I kind of did it this way where I'm like, okay, I got the command F40, and then it does the BNF stuff, but then it also prints out the tokens after. So we are good. Plus equals is the same as extend, apparently. So what we really want to do eventually is, tokenize. As this tokenizes, the bytes will go into the byte array. And that's the other thing that seems that I'm going to need to do is like, well, it has it, I have it. That's why I put it into an object. So it can just be there, you know, it can get self-index, it can get the line buffer, it can get the tokenized line and knows, you know, where the end of it is. I may do something along the lines of maybe I need to do something like that. Something like that. Yeah, we may need to go back when it fails and put it away. When we do some types of tokenization, like if there's an error, it might even rewrite the entire line as a token with the literal line in it. We will use in which case we'll use the entire line buffer. So again, that's why a lot of this stuff is here, the whole line buffer and the whole tokenized line. So we can manipulate them all however we see fit, but as long as we don't, you know, modify the program itself until we verify everything, then we're good. So cool. Yeah, that's the other thing too. Is yeah, if it's tokenized and it fails, I guess if we're not manipulating the whole line, I don't know. We'll see what happens. We're only manipulating the section. I'll have to look again at what the original basic does, but as I recall, the tokenizer here and the runner. That's the runner or the tokenizer? I don't know. But yeah, there's all the rules. There's all the tokens and then all that, and I did a pretty good job of converting these into little macros that are not necessarily super readable, but at least more modern, you know, than the other stuff. That used to be there also was kind of wrong in a lot of cases. Not necessarily wrong, but like it was just like plain bytes when it should have had something meaningful there instead. So I got to label everything correctly and much cleaner look at the and it's closer to the original source again, even though it's not exactly the original source. It captures the flavor of it. So I could also space things out a bit more to make them more readable, I suppose. But in general, this is really like, you know, unless you understand the rules, it's kind of crazy to look at. What's going on here? I'm going to another rule called FS, and then I'm going to this one, which, you know, to verify these things. So that's the name. That's basically a file string, and it can be any string actually. And then this is an end of statement, so which can be a couple of things. One of them is it could be a statement separator. The other one could be end of the line. And then this is like the end of a rule is return, and if it satisfies everything up to here, this means it's successful. So the rule succeeds. It doesn't mean necessarily the whole statement rule succeeds. This could be part of a larger rule. And it could come back and be like, I succeeded, and then the next part could be like, I failed. But once one succeeds, if you have or rules like these, where they're separated by or, then it'll be like, oh, well, you're satisfied, therefore I don't need to go on to this other one, which is like empty. I think this is an empty rule. Like, NSV2 equals comma NSVRL. Yeah, so, or nothing. Which is, I don't know, the original syntax that described these rules is a little weird, but I kind of kept some of it just for venerable, just to keep it for posterity. And then yeah, like print. Some of the statements use the same rules, of course. And yeah, the code itself is, it's a lot to swallow, but which is why I'm really trying not to necessarily copy and imitate it precisely, but just capture the spirit as I go along. So that's going to be fun. I'm having a lot of fun with it. Atari Basic itself, as you know, I've got all this stuff in here and in Sublime now to support that. So when you want to like run something like, I don't know, vertical blank demo, you just hit build and it'll open it right up in the emulator. But it takes a little while to load it because you're waiting for the emulator to do its thing. There you go. So there's my program. And all it does is make the cursor blink. Neat. But it blinks everything else too. But there you go. That's, And the integration I also have, you can say list p. And when you do that, magically opens up in Sublime. How about that? You have to set up, that it calls a command to come to Sublime, but that's one of the cool things about the command that I have. It translates all these weird characters from Atari ASCII into Unicode. So when you look at them here in the Atari and here in Sublime, you can see they are the same characters. H inverse percent T M at, backward line diagonal, forward diagonal, whatever. Yeah, so all those are the same because it converts it directly to Unicode. And then if I go to open this up in Sublime, or to open up in Atari again, the emulator, in this case Atari 800 emulator, then it'll convert it back into a ASCII on the way back. There's a couple characters, or one character that in particular can't be converted, 9B, which is the 155. So as long as you avoid that one, you can do all this with using characters like this. So this is actually the program code that's been just re-encoded in a ASCII. And you can put any number in there except for, again, 9B. Everything else. So I think you can even put 9B in there, like you're writing the program, but again, not with my system because it gets confused which is which. I think it does know the difference. If it's like at the end of the line, it knows it's a real one, like for the program, and otherwise it assumes that you meant the character, which is like an inverted escape character. 1B plus 9 plus 128 9B. Yeah, so pretty cool though. You can do the integration between the two is cool. So that's kind of why I started writing this basic thing. Is I was like, well, it takes a minute, to convert your basic program into something that runs, or to load it and then to tokenize it through the inside of Atari Basic. And I was like, wouldn't it be neat to do that for you and then send it over? So yeah, there's a bunch of soft side code that I brought over. If you're a fan of Soft Side Magazine, this one always fails the first time, so I have to press break. I think is, or at least that. I have to run it twice. There we go. Player one. Bob. Bob's turn. So I forget how I did this. Yeah, I tweaked it a little bit so it works better than it used to, I think. And you just, you know, forget which button I gave it. Return, maybe. Something like that. Oh, yeah, I think you have to press a number. 4. There we go. Golf. There we go. 2. Yeah. Right? Remember this kind of stuff? You would type it in. Nine. Oh no. Too hard and wrong angle. Oh, I suck. So yeah, this was a fun one to type in. But yeah, you can now. I've been going through some old magazines and grabbing some of them and typing them in. And sometimes like they're not that hard to type in. Some of them take a long time. This one took a while. But I did finally get it done, and so we do have a thing called Hopper Game of Skill. And does use the keyboard joystick, so we're good there. I just have to like figure out what buttons I used. I think that's it. Press button to start game. What button did I use? Z, A, Option, Alt, Shift. I think it's left shift. I don't know why I used that, but I did. Yeah, remember this kind of stuff? Not bad for basic, right? But it's actually got some assembly in it, so it's cheating a little bit. But also, there's ways to make this much smoother. And of course, if you did see the original official Frogger game for the Atari, it did a very good job. And there were others like Preppy, which was like the original Frogger game, and Preppy 2, which was like more like a mowing the lawn game. But as far as basic stuff went, this was a pretty impressive one for a type-in game. I enjoyed typing it in and playing it back in the day, and it had some cool sound effects. Hopper or Baby, remember this one? Yeah. So yeah, and then there was this one as well, Maze Source. You remember this one? I cleaned it up a bit as well and made it kind of nicer in a couple of ways, and I also kind of made it in more of a game, like you can keep playing after you win. So let's do it. So there it is. Oops. Sorry, I have it on speed. Let me run it again. Yeah. Kind of annoying, huh? Woo! Yeah. But this is made as generator in real time in BASIC. I did some tricks to make it run faster. So it actually does generate the maze, but faster than it used to. Basically just remembering where the last junction was and going back instead of retracing its steps. So as long as you grab food, it stops the time from going down. So that was the one thing I changed. And but the rest of it's pretty much the same. You just use the joystick to get the food. And once you eat all the food, you win. If the timer goes down, you lose. And it's great sound effects for a basic program, as you'd expect. Oh, I'm gonna lose. And then I put in some music when you win. I made that music. Isn't that cool? And you just press the button again, and it makes a new maze. Over and over it goes, over and over. Nothing chasing you, just relaxing maze traversal. So yeah, that was pretty fun. There's a thing called microtext, which was actually a little word processor that someone made. So check that out. How about that, huh? And then I don't know how the arrow keys thing works. Oh wait, I have to turn them off. I don't know how it works with the arrow keys. I think maybe. Oh, look. But yeah, and you can save, load, review, edit, print, blah. So pretty cool stuff. And of course, you can do things like add formatting and things like that, I believe. So pretty neat. All, written in BASIC. Why not, All you're doing is saving, data to a disk. And if you really, wanted to work it out, like back in the day, one of the things I was also working on before I gave up my hung up my Atari Basic hat was an inventory system for a video store, and I was starting to write that with like random access to sectors on the disk, and doing it the right way basically, and making it more of a database, and having things have like a tree-like search structure, so it'd be easy to find things, and yeah, it was really working out well. And you would you had to just like anytime you wanted to add something, if you needed a new section or whatever, you had to add that first. But it was pretty cool. It was coming together really well. And but again, it was like at the end of my tenure of like of secure, stable living, and I was like, damn, I have to move. So couldn't keep doing it, unfortunately. One of the things I did add in my basic handling is you can put in comments like this, and they get stripped out when it gets sent to the basic to the interpreter. So you can put in your extra comments and do whatever to like spell things out. A lot of us typed in this one. I think you might. I'll just show it to you. I don't know if I'll play it a lot, but you might have seen this one. Oops. Yeah, you might have seen this one. You move around, shoot, and you have to like. First, there's one saucer and one set of three, and then there's three sets of two, and then there's three sets of three, and then they just keep coming after you. And this one was fun. I had trouble typing this one in, and I think it didn't work right, but this isn't bad. I could see speeding this one up and making it work better, for sure. Oh no, I died. You can tell because I got definitely hit. It uses real player missile collisions. Woo! Pretty cool. So it's a nice little demo of player missile collisions. A lot of folks typed in Sheldon Lehman's Space Attack, which I put all the comments in from the magazine. So if you want to read them and understand all the things that it does without having to try and decipher the magazine, you can. You don't necessarily have to read this terrible font. You can also read this in a better font. This is just the one I picked, but for obvious reasons. And you can kind of look at it, you can see the code itself isn't much. And this is a Space Invaders game that was originally, I should say eventually, republished as Pack Invaders, something like that. But it has some bugs, like you can go way off the screen and then overflow and it crashes. It's not a great version of Space Invaders or anything. It's fine, you know, it's fine. You know, while you're waiting for it to load, it initializes a copy of the character set to the screen for you. And eventually it'll say, start playing. So it's got weird bugs like, what's with that noise up there? Okay, that's funky. That's something that it just has there. The motion I think is kind of cute. I think that's cute, kind of cool that it has this weird like slowing down kind of goofy animation. I really like the designs on little creatures that he did. I thought they were very cool. I don't know if this. Let me see if I remember right. Does this go all the way to the edge, or does it? Nope. It doesn't change how far it goes based on which ones you've killed, but it does change when you die. Like if you kill a whole row, then you have to, it has to go down further to kill you. So yeah, pretty neat. But it's got weird bugs, and then like, as you can see, if I go way off the left, it just crashes. So very dumb. So there's some things that could be fixed. And also, it's like there's a lot of code that runs down here, so if you could make it all run up at the top, it would be better. You want to get rid of go-tos and go subs as much as possible, but if you do have them, put them at the top, because they'll go there faster. They'll return slower, maybe, depending on where you're calling from, but at least it'll get there faster. Well, it depends. And then there's Space Rescue, which you also might have seen. I might have shown this. I might have shown all this to you before last time I did a stream, but it's always good to revisit these. I enjoy these. Oops, it's not going to let me resize the window. I've got it set to like integer only or something. Something like that. There you go, Space Rescue. So this one is just doing, obviously, 3-color palette rotation, and then it's using basic text mode, essentially. So you release your ship, and you're supposed to land on the platform, not to crash into the ground. So I have to get close to the platform, release my little dude. Right? Again, this is another one I think I didn't type in great, but once I did, I was happy. Yeah, a little happy guy. Oops. I'm supposed to fly up to the back up after I get him. I'm supposed to go back up. So I'm no good at this yet. I need practice. Oh. Wow. Then you have to push start to play again. Just cause, might as well. Basically, you should make everything work with the joystick button only. So I may fix that. But yeah, that's stuff. And then there's mapping. The Atari had some demo code. I threw that in here. And then some of this other stuff is just stuff I wrote. Like I was messing with trying to make a little DOS thing. A little this actually is Sheldon Lehman's character editor, which isn't very good. So I say we should fix this soon in some way. We get this working better. So in the world of Atari Basic, whatever, it's cute. The main thing that's good about Atari Basic is you can prototype stuff. You can make fun little games like that, which I think are great. The Soft Side magazine was, fun, really fun to type in stuff from. And sometimes you got some really amazing stuff with just surprising stuff. Codfish Ball is one that surprised me. I think surprised a lot of people. Which is just It's very fast in terms of its little animation. I think I'm just missing. I got a score of 0, so I must not be doing... I'm doing something wrong, obviously. Or I typed it in wrong, maybe. Who knows? But either way, there's a game called Changing Hearts, which I can never win. Even though I'm sure it's simple rules. Hopper. Oh, there's two different versions of Hopper. One is GTIA, one is CTIA. I put in the GTIA version because that's what most of us have in our emulators. So I'm waiting for this one to work. So does it or not? I don't know. If it doesn't, that's fine. It uses player collisions. So it may be that it needs to use a different mode. Like, look at my score, 0. What is that? Yeah, I feel like it's got to be using the wrong mode or something. Display GTIA, CTIA. Doesn't matter. I don't know. Maybe it's just a bug in the... Maybe I typed it in wrong. I forget where I got this from. Oh, you know what? Some of this stuff I did get off of discs, so I might be cheating a little. But yeah, so I'll figure that out eventually. See what's going on. For now, put that away. But yeah, being able to work with Atari Basic has been cool. Learning a lot about parsing of language. The next thing after that is again, I'm get into some real, retro stuff. Especially once this next version of Marlin is out, I have a little time to take a sabbatical and do a little bit of side stuff to kind of get my chops in order and learn more C++, standard template library, and kind of maybe I'll build something that's like a mini motion system or something that's just to exercise that, or to get used to it, and not target anything serious, but just see what I can build using C++ straight up, and that'll be fun. And but on the side, I want to do at least one game for the Atari, and while I'm at it, port it over to the Commodore 64, since the 64 Ultimate is out now. The Commodore Ultimate looks great. Ultimate 64, I have one in my collection. Actually, I have an Ultimate 64 FPGA emulated. It probably needs a firmware update at this point, but yeah, and I have the original bread bin and motherboard, and I can put a... I've been meaning to move the SID chip over, but I haven't done that yet. But it works great even without it. It's great. So yeah, I can get into that. The new one has like up to 3 SID chips, so pretty cool. It does some amazing sounds, like just crazy. So I'm thinking about getting the new one, but if I do, it's gonna have to pay for itself, so I'm gonna have to make some games with it. So yeah, 64 is a very interesting and fun platform. It's got some challenges, but it's also it's got some real power to it. So you can do like big scrolling, platformers or whatever. I want to do something sort of on that level. I've never done a platformer completely, so it would be a fun thing to do. I kind of like started on one a little bit with one of the levels in Bill and Ted is like a platformer, but it's not very good. Very random, too hard. So something that's more reasonable and has something a little more fun to play on the Atari and on the C64 that has kind of modern aesthetic and stuff. I think it'll be fun, and the music that you can make on a C64 can't be beat. Although you can come pretty close with the Atari if you like. The music in say Ball Blazer is pretty good. So something on that level is fine. If you don't need anything too fancy, a couple of voices with a little bit of percussion, and some bell type sounds. Do. I was getting pretty good at making audio stuff when I was last working on the Atari. That was one of the other things I was building was tools. I was making a sprite editor and a sound editor, and I was coming along with both of those And the sound editor was going to be very interesting because you never know what you're going to get, you know. I'm like, you just change different parameters in time over time, and you say, oh, well, let's generate one that is like this, change this parameter over, you know, from here to here in this amount of time, and let's change this parameter at the same time, you know, but only half as much or whatever, and they happen at the same time, and you can make anything modulate anything else, and so that could be really fun. So I was looking forward to doing that, but I never got quite as far as I wanted. Thing is, if you make really good audio modulation on the Atari, it's like you're using up some of the processing. You're stealing it from your game, so you have to sort of balance. You know, do I want to make really cool modulation and have a awesome title music, and then dial that back for the game and just have like a little rhythm in the background? So yeah, fun stuff. But I'm really looking forward to what I can do with it. Not trying not to push it to, you know, sort of at the end of the Atari's lifetime, they were doing things like making games that were high res and, you know, graphical, that were meant to be deployed on the PC as well. And it was not didn't perform great on the Atari. Things like, I'm thinking of like the pinball construction set and stuff like that, which were cool, but at the same time, it felt almost out of place because it was like next level. But the but if you worked within the limits of the Atari, like if you made games like Necromancer, or you made games like Whistler's Brother, and stuff like that, like you could make stuff that was really like very exciting and worked within the limits and did some cool stuff. So I don't know. I'm gonna try and make some things that push what we can do, and I don't know, maybe an endless shooter. I don't know, endless runner. I don't know. We'll see. But there's stuff to be done. So anyway, gotta pick something and make it. That's the real trick. And I have some ideas, so we'll do those. But I gotta get used to it. And that's what this is about. Some of the stuff in this pile is um, code for the future. Like, how do I build um, with see, like there's VCS, there's VASM, which is like versatile assembler. So that's one I've been exploring. Maybe I'll try that. There's DASM for the VCS. There's BDOS, which is this one. Oh, this is actually just code for my BDOS, like code. Um, so something like this is at ATSM. This is for the Mac 65 compatible ATASM assembler. So I'm basically gathering different assemblers and trying to figure out which ones I would use. Typically, it's going to be CA65 or DASM. So that's kind of what I'm looking for, is like gathering the CA65 stuff that I can and using that. So the Atari Basic code is kind of a good example. This stuff here, because this actually builds with CA65 and has things like includes, and it has macros, and it has, you know, and it works as a cartridge, and it loads, and it has all the right stuff. So getting this to work with, you know, taking this as a basis and then emptying it out and then putting new code in shouldn't be too hard. So that's a good place to have a starting point. And you have these ink files. And then I made a source book ink, you know, just to go with this. All of this is already published on GitHub. You should go check it out. It's in the Atari's Basic Source Book folder in the 6502 Tools project. Yeah, go check it out. I'm gonna go have a retro game session. I'll see y'all pretty soon. Have a Merry Christmas, everyone. Have a happy holiday, whatever you're celebrating, and I'll see you soon.